So what we see is that in this case it is already in a canonical form because we have z which has only value of 1 in its own row, s1 is one basic variable, s2 is the second basic variable, s3 is in the third basic variable, and all rows have at least one basic variable. What we do identify is that we add a new column, and what you should have filled in your basic variable column is that s1, s2, s3 are the new basic variables for these rows. In order to check if optimality has been attained or not, clearly we have two negative values of the variables, and the smallest negative value is 450 with a negative sign, and that will be our pivot column. Next, we have to identify the ratio of the right hand side to the value of coefficient of y, and the exiting variable will be the one with the minimum positive value of that ratio. So if we do that, the first row is 35 divided by 1, which is 35, the second is 38 divided by 2, which is 19, the third is 50 divided by 2, which is 25. So the smallest ratio is 19. So our leaving basic variable will be s2 and the entering basic variable will be y. So here in this slide I have shown that y will be the new basic variable, and once you do that, in this case it clearly shows that we have to perform an ERO to get y to become the new basic variable. So please go ahead and fill the next table with the EROs that you need to perform and the answers that you get for after you perform those EROs.